Welcome back, guys, to episode 4 of the Python for Beginners tutorial series. In this episode, we're going to be covering lots of data types and a bunch of their properties and functions. So without further ado, let's just get started. Today, we're going to be going over strings, lists, and dictionaries. The timestamps are on screen as well as in the description. Let's get started with just a small review from last episode, and let's cover the essentials. So first, string concatenation. We covered this in the last episode, but let's just comment out this over here and run this program. You can see that it says whoa multiple times because we're concatenating this space with this string over here, and then we're just multiplying it multiple times to copy it 12 times. So that's string concatenation. And now for getting the length of a string, we just use this len function here, and this is very useful for strings and also lists. So once we get the length here, it will print out the length. So you can see 7, it means it's 7 characters long. So first, let's try converting things to type string. So you can see here we have this example. Let's just go ahead and print this out and see what happens. So let's go to the terminal and just press this. So you can see that it says class string and then 1, 2, 3, class string 1, 2, 3, class string 1, 2, 3. So if you remember from last episode, this is called an integer, this is called a list, and this is called a set. So we won't be going into sets too much in this episode because they are mostly for more advanced coding, and most of the time you can just do everything you want with lists. And you can see that we're converting it to a string and trying to print out the string. So you can convert any data type into a string. So indexes. Strings are accessed through slices. That's what we call a part or just a character of a string. So we have a string defined here and it says, hey there. So let's access its slices through square brackets. So it's in this form, so it's string, its first index, which is inclusive, and then the last index exclusive, and then step. These are optional. You can just put these colons if you want to skip one of them, and it'll automatically complete it. So for example, a string has indexes like this. So let's say the string is just example. If you want to access any part of the string, well, let's access this x over here. You can access it using 1 or -6. The negative numbers go backwards starting from -1, while all the positive numbers go forward starting from 0. Why does it start from 0? Well, most numbers operate that way because of 0 and 1, the binary system. So most things start counting from 0. Just a weird little quirk that Python has to make it more accurately represent how the computer works. So let's go ahead and try printing out that string slice over there and comment out these characters. So let's run this, and you can say that it just says hey, because 0 to 3, if we remember, 0th index is this character and it's inclusive. And then the third character is, well, this is 0, 1, 2, and this is the third character, but it's exclusive, so we don't count this. So it's just this character, just these 3 characters over here. That's a string slice. So now strings are immutable, so you can't overwrite certain sections and only the entire thing. So that's very important to know because you'll encounter an error if you try changing like just this, for example. So now let's go through these options. Like I previously mentioned, you don't have to specifically mention the indexes. Instead, you can just put the colon here and not put anything there, and it automatically fills it in. Python reads it and fills something in. So this would be the start. This would just be the last index, so it will include everything. And the step is how often it skips characters. So by default, it's 1, which means it doesn't skip characters. 2 means it skips every other character. So it'll be H, Y, and then T, E, E, and then nothing else. And you can also go backwards, but we're going to take a look at that in just 1 second. So let's comment that out, clear, and let's print this. Let's print this. And you can see how it's H, Y, T, E, E. You can make the step negative, so it'll count backwards. So let's go ahead and take a look at this, and you can see that it goes backwards. Very cool. Let's go ahead and create a new string here. and we can find the location of a string, we can find the other location of a string, and we can replace certain sections. So let's go ahead and just try one of these things one at a time. And now let's run it. So you can say it says 0 here because it's finding the first Q, which is the 0th index here. So like that, run it, it says 36, and that's because it's the last character here. So it's probably the 36th indexed character. So that's also useful. rfind means reverse find, and it can be helpful to search from the other way instead of from the front. So now let's try replacing. So let's copy this and paste it into its print function. So what replace does is it takes a string and then it finds a section in it. So let's say this QWERTY, and it replaces it with this other string that we want to replace it with. And it doesn't change the variable, it returns a new string that has these changes. Now this over here means how many times you want to change it. So if you specify 1, then it'll only change the first occurrence. If you specify 2, then it'll change if there's multiple occurrences. But if you set it to -1, it'll just change every occurrence. Let's go ahead and run this. And you can see that it has taken the original value of the string, replaced this QWERTY to high, and then printed it out. So note that this isn't, it hasn't changed S because strings are immutable. So you can see it's still unmodified here. It's just returned a different string with these changes. So that's the replace function, also useful. So this will count only non-overlapping occurrences. So it won't continuously count like 1, 2, and then 1, 2, and then 1, 2. It'll count 1, 2, then 1, 2, and 1, 2, 1, 2. So count feature, very useful, and that's you can see it says 5 here, and that's because there's only 5 non-overlapping occurrences here. Alright, so now we're going to be covering lists. Lists are really easy to learn since they're almost like strings, just a bit different with some different types of functionality. So pretend you're a wizard and you have these kinds of spells and you want to change certain spells. Unlike strings, lists are mutable, which means you can change certain parts of the list without having to overwrite everything. So let's say we want to change the first spell, fire, to something else. Well, fire is at the 0th index, so we're just going to access it by putting this 0, and then we're going to change it with the spell we want. And to test out if this works, let's just print it out and see what happens. So you can see that it has replaced the 0th index with what we wanted. Or if you want to change a list of things, you can put a colon here. So now it'll replace fire and ice with, let's say, dark earth. And you can change a list of elements over here. And just like in strings, you can also pull these values directly. So let's just copy this and paste it in here. So you can also just take subsections. So if it's multiple, it'll be returned as a list, or if it's just one, it'll be returned as just a simple string, as you can see over there. So now let's try using some of the functions exclusive to lists. So let's go ahead and delete this, and let's try out the first function, the index function. So let's say you don't know where fire is in this list. Let's say it's a huge list and you have no idea where it is. What you can do here is you can use the .index method. So let's go ahead and print out spells.index and then put in our element. So let's say fire. Let's clear terminal, run, and you can see it returns 0 for the 0th index in the list. So .index can allow you to find elements or items in a list, which can be useful if you don't know where it is. Now sometimes you want to add on to lists, so what you can do here is, let's say we do spells dot append. This is the method to add items to a list. It adds it specifically to the end. So let's put in dark, and now let's print spells. Let's print spells, and you can see it's added to the end. So you can append things that way, or you can also append it by doing the plus equals operator and then putting dark, although I do not recommend this because it is not that readable. So you should basically never use this. Or you can use dot insert. So let's say we want to put dark at the very end. Well, let's find the length of the spells and let's put it at the end. And as you can see, it also puts it at the end. Generally, if you're just generally putting it at the end, you want to use dot append because it's the most readable. However, you can use dot insert here, or if you want to specify it, let's say I want dark between fire and ice, or just one after fire, then we can actually do a combination of things. So let's put I for index is equal to spells dot index fire, and then we can put I plus 1 because we want it after the fire. So we print that, and you can see over here that it shows it afterwards. So append, index, and insert are useful when changing things or adding things to a list, but sometimes you also want to remove things from a list. So here, pop and remove is useful. So we have our spells over here. Now let's try popping something from the list or removing it from the list. Let's say I really don't like this lightning spell over here. So what we can do is, let's first show the end result, so print spells. And now let's pop the result over here. So this is the second index in here. So what we can do, spells dot pop 2. So we run it, and you can see how it has removed lightning over here. So again, useful when you're changing lists and removing things. And also it's important to note that if you put some index that isn't valid, because obviously this list is this size, then an error will occur because the index is out of range. Now something really nice about this dot pop method is that you can actually print out the value that you pop out. So let's paste it into here, and it should print lightning, as you can see over here. So that's one added functionality that could help when you're coding. And there's also another method to remove an item from a list, and it's the dot remove function. So let's print out the end result once again. And now let's use the dot remove function. So spells dot remove, and it removes the first occurrence of a value. So let's remove this ice item here. Let's remove ice over here, and it'll search for ice and remove it in our list. So now you have just a list without that ice part there. So those are the major functions when it comes to list. There's many more, but in general, index, insert, pop, remove, and append, those are the ones that you're going to be using the most when it comes to normal lists. Now there's the more mathematical side when it comes to Python. So let's say you have a list of ages over here and you want to sort it. What you can do is, let's print out the end result over here, print ages, and we'll do ages.sort. It's an inbuilt method. So let's go ahead and print this out and see what we get. And you can see how it shows 2, 8, 10, 12, 13, 18, and 80. Now if we do reverse is equal to true, because by default it's false, and print this out, you can see that it's in descending order instead of ascending order. So that's one way to sort things in a list. You can also use sorted. So ages is equal to sorted ages, and it will return the sorted list. And then just print out ages. So it'll show you the sorted out list. And if you want to reverse it again, you can also do dot reverse, and that reverses it. So this is how you can sort or reverse lists when you're dealing with data. But let's just remove this line of code for now, and let's try doing some more mathematical operations on it. So let's say we want to find the maximum element in here. Of course you can sort it, but instead what you can do is type in max and then the list, and you will find the maximum item in this list. There's also min, which does the opposite. It finds the minimum, which is 2 in this case. Or there's also sum. So if you want to sum all the ages, and let's say you want to find the average, so what you can do is just simply write this. Then boom, you can find the average age by getting the sum and getting the length of the list. Alright, so now let's work with dictionaries, which is my favorite data type out of all the data types in Python. So let's say you have a bunch of spells and their respective damages, and what you want to do is just change it up and extract some parts of the dictionary. So let's say you are making a game and need to see how much damage fire does. So what you can do is print out the spell damage and then access it. So use square brackets here, and as you can see here, you can access it by putting in what we call keys. These the things on the left are keys, while these are values, and you use keys to access the values. So let's say I do a fire spell, we can see how much damage the fire spell does. So if we run it, we can see that it does 10 damage. Very good. And there, you can't use colons here because that doesn't make sense when it comes to a dictionary, because like a real dictionary, you put in some kind of keyword and then you get some information out of it. So now let's say we want to extract just all the spells. Well, what we can do here is we can just set up a situation where we need to make a one-liner. Okay, so now what do we code here? Well, we can code spell damage, dot, and now we have 3 options here. We can do dot values, dot keys, or dot items. So just for now, we're going to do dot keys because we want to access the keys, not the values. So dot keys, and this will return an object of all the keys. Now before we can really use this, we have to put this in a list. Otherwise, it's just going to remain as that object type, which is better on memory, but it won't be usable. So we have to convert it to a list. And now if we print this out, you can see that it shows all the keys in this dictionary, which is very useful. But let's say you want to take all the damage values, so the 10, the 20, and this 20 over here. Well, just replace this dot keys with dot values, and you will get the damage from each of these spells, 10, 20, and 20. And now let's say you want to get both. You want to get everything as a list. What you can do here is put dot items, and dot items will return tuples with the keys and the values, and it will put everything in a list. So these 3 methods are very useful when it comes to pulling out data from the dictionary. Additionally, let's say you want to update the dictionary. So if you're just adding something to the dictionary, so let's set up a situation. Let's say you're adding a new spell. What you can do here, just put the square brackets and then type in something else. So let's say I want to type in water, like a water spell. And let's say that does 15 damage. So you can type that in, and it will show the dictionary with that new key. And if you want to edit any key, you can just simply replace an existing key, so fire for example, and change this 10 value to be 15. So let's go ahead, clear this, save the program, and let's run this. So you can see that we've changed the fire from being 10 damage to being 15 damage. Now this should be good enough for most cases, but two more functions that are very helpful to learn is the .update and .pop function. So let's say we want to remove a spell, right? They have forgotten a spell because they want to learn something new. We can use .pop, and just like a list, it pops based on, instead of an index this time, it's based on a key. So let's say we pop dark, let's save and run. So you can see that the item is no longer there. The item is just the key and value pair. So if you want to remove something, .pop is your friend. Additionally, there's the .update method. So let's say that there's some more spells that are going to be changed. So let's say, because I'm a Persona 5 fan, you're combining two personas with different spells. So we have this first set of this first dictionary of spells, shouldn't be saying set in this situation. You have this first dictionary of spells, which is fire, dark, and wind, and let's say you have another dictionary of spells. And basically what you want to do is combine these two dictionaries together, or you can use this .update method. And basically if there's any keys in here which already exist in this dictionary, it will simply overwrite them. And if there's any new keys, it'll just add it to the dictionary. So let's go ahead and clear, and let's run this program. And you can see how it shows fire is now 5, dark is now 10, wind is unchanged because we didn't change it when we updated the dictionary. And then it has all of our other spells over here. Congratulations! You're over halfway done this tutorial series. Over the next few videos we'll go over loops and some things to make your code more powerful. Anyways, bye.